Okay, notice for 7D, the question is not as direct as the three questions that we had from 7A, B, and C here. So the angle theta now is not part of the direct angle of a right angle triangle. Okay, so what do we do? Okay, firstly, the important thing is you need to identify which are the right angle triangles in the diagram. So the most direct right angle triangle that I can show you first is actually this triangle ACD. And the other one will be A, B, D. So now, notice that angle theta is actually equivalent to angle BAD minus of your angle CAD. So this means that we can solve the question if we can find the angle BAD and angle CAD respectively. Okay, so AD. So 15 is actually the hypo of angle BAD, and 7.2 is actually the adjacent. So from here, we have adjacent and we have hypo. So yes, we are using cosine. So cosine angle BAD is equal to adjacent, which is actually 7.2 divided by 15. So angle BAD is equivalent to arc cosine 7.2 divided by 15. So what we have is 61.314 when I truncate to 5 SF degrees. Now, please take note because this is actually not our final answer, so we do not round off the answer yet. Okay, so now on to the next one, angle CAD. Looking at the smaller blue triangle that we have. Okay, notice that your 9.6 is actually the hypo. And my 7.2 is actually the adjacent of the angle CAD. So from here, I know that likewise to the previous example, because it's adjacent and hypo, so my cosine, maybe I just, angle CAD is actually equivalent to adjacent over hypo, which is 7.2 over 9.6. So this means angle CAD is equivalent to arc cosine of 7.2 divided by 9.6. So keying in into the calculator, this gives me 41.409 when I actually 409 degrees, or when I actually truncate this into 5SF. If you are able to store the values inside a calculator, it will help a lot when you're doing your calculations over here. Okay, so we are done. We are mostly done with the question already. All we need to do now is to find our angle theta, which is simply what? Theta is actually equivalent to 61.314 degrees minus of 41.409 degrees. So this gives us 19.905 degrees. And we actually need to round off to 3 significant figures from the requirements of question 7. So this gives us, as a result, 19.9 degrees 3SF. Okay, now going on to question 8. Now, question 8, likewise to question 7D, is not a very direct question, and there are two parts to it. So the first part itself requires us to actually find the length of QS. Now, it is not very direct in a sense, because if you just look at triangle RSQ, the details of this triangle is actually quite limited because we only know this length 12. Okay. However, we do note that the question has given us information about PS, which is 10. So this should actually give you a hint. Should I use this entire length QP in helping me to find what is QS? So let's give it a try. So in part A, to find what is PQ, actually I realized that I can look at the bigger triangle over here. So this PQ itself is actually the adjacent side. This whole part, the adjacent side. And 12 is actually the opposite of angle 34 degrees. So as a result, if I have O and I have A, so yes, we should be using tangent 34 degrees is equivalent to opposite over adjacent, which is 12 over PQ. So from here, PQ is actually equivalent to 12 divided by tangent 34 degrees. Equating this, what I actually find is 17.790 cm. Okay, so as a result, can I find my QS? Yes, I'm able to find now, because QS is very simply 17.790 minus of my 10, which gives me 7.790. And in this case, we actually round off because it wasn't an exact answer before. So actually this gives me 7.79 cm. Okay. Okay, on to part B now. Now that we know that QS is actually 7.79 cm, okay, let me just rewrite this so that we are a bit clearer now. So actually this is actually my 7.79 cm. So from here, in part B, now likewise to the previous 7D, okay, you realize that this beta over here is actually not part of directly part of a right angle triangle. So the idea is very similar to what we actually did in 7D. Okay, so first thing first, I will need to find what is PRQ. Now, do we need to use any trigonometric ratios to find angle PRQ? There is no need to do it because actually you realize that for triangle PRQ, we already know this as 34 degrees and we know the right angle over here. So very simply, angle PRQ is equivalent to 180 degrees minus of your 90 degrees minus of 34 degrees. This will be angle sum of triangle. So this gives me 56 degrees. Okay, so what we are left with now is for us to actually find angle SRQ. Okay, so to find angle SRQ over here, we notice that 7.79 is actually the opposite side, and this 12 itself is actually the adjacent side. Okay, maybe let me mark down with a colored so this itself is actually now the angle SRQ that we need to find. This is now actually the opposite side, and this is now the adjacent side. Okay, so tangent angle SRQ will actually give us opposite 7.790 divided by 12. So angle SRQ is equivalent to arctangent 7.790 divided by 12. This gives me 32.990 degrees. So the final step to find beta is actually equal to 56 degrees minus of 32.990 degrees. So this gives us 23.009 degrees. So when I actually round it off, this will give me 23.0 degrees. Take note, this is in 1 decimal place because it is an angle and it is not exact, so we round off to 1 decimal place. So that's it for this question.